let us see the word solution for this 8th question. So given diameter of cone which is 1.4 meters, so radius of cone which it will be 0.7 centimeters. It is in centimeters only, not in meters. Centimeters. So it can be written as 7 by 10 centimeters for our convenience. And height of the cone and cylinder both are same. So height of the cone 2.4 centimeters. And height of cylinder which is also 2.4 centimeter. Therefore, surface area of remaining solid is equals to curved surface area of cylinder plus curved surface area of the cone plus area of base. Here the base is circle, area of circle. So 2 pi RH plus pi RL plus pi R square. So here we have to use the formula L square is equals to H square plus R square, since we require here slant head of the cone in this case. So already height is there and radius is there, so we can get obviously L. So in these three we can take pi R as common, since radius is common in all the cases. So 2H plus L plus R. So L value we are going to obtain from this. Radius is 7 by 10, height is 2.4. If you substitute the values, you will get the answer. The next question, 9th. So in the 9th question already figure is there that a cylindrical with two hemispheres whose dimensions are height of the cylinder is 10 centimeter and base radius is 3.5 centimeter. So here given radius of hemisphere cylinder both are same here. So hemisphere is 3.5 centimeter. So radius of cylinder also 3.5 centimeter. Height of cylinder 10 centimeter. So he is asking to find the total surface area so which is curved surface area of cylinder plus 2 into curved surface area of hemisphere. So that is curved surface area of the cylinder is 2 pi RH plus 2 into 2 pi R square. So 2 pi RH plus 4 pi R square. So we can take 2 pi R common. So in the brackets we can make it as H plus 2R. So substitute all the values here. In place of radius we have to put 3.5 and height 10 centimeter. So this is about exercise 13.1. Now 13.2 exercise first question we will see. So in this question is clearly saying that a solid is in the shape of the cone standing on a hemisphere. So a cone which is standing on the hemisphere with both the radii being equal to 1 centimeter. So radius of both will be 1 centimeter and height of the cone is equal to radius. So height of the cone is 1 centimeter. So he is asking that find the volume of the solid. So it is exercise 13.2. So given radius of cone 1 centimeter height of cone 1 centimeter, radius of hemisphere also 1 centimeter. So it's asking volume. So volume of solid is equals to volume of hemisphere plus volume of cone. So volume of hemisphere we have the formula 2 by 3 pi r cube plus volume of the cone we have the formula 1 by 3 pi r square h. So in this we can take 1 by 3 pi r square common. So here left is r plus h. 2r plus h. Why? Because 2 is there here. So 2r plus h. In place of radius put the value as 1. In place of radius put value 1. And in place of height of the cone put value as 1. So your answer should be pi. So don't touch the pi value, keep as it. Let us go with the next question, second. Same 13.2 exercise, second question. So cylinder with two cones on the top and as well as on the bottom. So there is a figure like this, cylinder with two cones, and diameter of the model is 3 centimeter. So total diameter is 3 centimeter, and height of the model is, total length is 12. So total length is 12 centimeter. So each cone has a height of 2 centimeter. Cone height is 2 centimeter. Find the volume of the air. So we have to find out the volume of the air. So given diameter of cone which is 3 centimeter, so radius of cone which is 3 by 2 centimeter. Don't make the calculation complex by making it as 1.5. It's better to make it as fraction so that we can get cancellations. So height of cone 2 centimeter, radius of cylinder which also will be 3 by 2 centimeter, height of cylinder, so which is 12 minus 2 minus 2. Why? Because on the top 2 centimeter and on the bottom also 2 centimeter I need to subtract. So it will be 8 centimeter. 8 centimeter will be the height of the cylinder. Therefore, volume of solid is equals to volume of cylinder plus 2 into volume of cone. So volume of the cylinder formula we have pi r square h plus 2 into 1 by 3 pi r square h. So we can take radius as common since it is both common only. So we can take pi r square common. So left terms are h 2 by 3 h. So this h stands for height of the cone and this h stands for height of the cylinder. So here you need to substitute 8, here you need to substitute as 2. You will get the answer. Pi value you have to take it as 22 by 7 until and unless they will sit to take 3.14. Okay, next let us see the third question. So in the third question, there is a cylinder. In this cylinder they are keeping the gulab jamuns in the shape of a capsule. Okay, they are keeping on the in the shape of the capsule. So length of one gulab jamun is 5 centimeter, diameter is 2.8 centimeter. So if you observe here, if I take a gulab jamun like this, so it is in the shape of a cylinder with two hemispherical ends. So given diameter of hemisphere which is 2.8 centimeter, so radius of hemisphere (1.4 centimeter) and height of cylinder, so it will be 5 minus, so total length is 5, so here it is 1.4, here also 1.4, means 5 minus 1.4 minus 1.4, 5 minus 2.8, so it will be 2.2 centimeters. So this is the height of the cylinder. Why? Because from total I have to subtract this 1.4, 1.4, so that only I will get the height of the cylinder. Now the volume of solid is equals to volume of cylinder plus volume of two hemispheres. So volume of the cylinder, we have the formula as pi r square h plus 2 into 2 by 3 pi r cube. So since radius is same in both the cases, we can make use of radius. So pi r square, in the brackets we can put h plus 4 by 3 r. So in place of radius you need to substitute the 1.4 and height is 2.2 and here radius is 1.4. So after doing this, he is saying that 30% of its volume. So this is for one gulab jamun, we are finding volume of one gulab jamun. Instead of solid we can write one gulab jamun. So like this we have 45 gulab jamuns. So whatever the answer that you are getting, you have to find out volume of 45 gulab jamuns. That is 45 into whatever the volume of one gulab jamun you are going to get, you need to substitute it in this. And thereafter he is saying that 30% of its volume. So multiply with 30%, you will get the final answer. Next, let us take the fourth question. So in the fourth question, a pen stand is there in the shape of the cuboid and conical depressions. So you can observe the figure. So there is a pen stand like this with conical depressions, means whatever the circles are there, the holes, it is in the shape of the cones. So with the conical depressions, so dimensions of the cuboid are dimensions of cuboid. So length is given as 15 centimeter, breadth 10 centimeter and height is 3.5 centimeter. And the radius of each depression is 0.5 centimeter. So radius of cone 0.5 centimeter, height of cone, depth is nothing but height. So height of the cone is 1.4 centimeter. So here we need to find out volume of wood in the entire stand. Is equals to volume of the wood in the entire stand is, so there are totally 4, okay. So volume of cuboid minus 4 into volume of cone. Since we have 4 conical depressions, so volume of the cuboid is LBH minus 4 into 1 by 3 pi r square h. So if you substitute the values are here, length, breadth, height, and pi r square and h. So we get the answer of this. Next, fifth question of 13.2 exercise. So he is saying that a vessel is in the form of an inverted cone. So this is the inverted cone. Like this, there is a vessel and of height 8 and the radius of its top is 5. So radius is 5 and height is 8. And height is 8, is filled with the water up to the brim. So we are filling with water in this, and we are throwing the lead shots of spherical shape of 0.5 centimeter. So we are filling with lead shots in this. These lead shots will be in the spherical in shape, and 1/4 of the water is flowing out. Find the number of lead shots. Okay. So given height of cone, which is 8 centimeter, radius of cone 5 centimeter, next radius of sphere 0.5 centimeter. So in this case we need to find out how many number of lead shots. So volume of cone is equals to n into volume of sphere. Next, so volume of the cone is 1 by 3 pi r square h, n into volume of the sphere is 4 by 3 pi r cube. So pi gets cancelled, and substitute the value is 1 by 3 into radius. So this is radius, stands for cone. So 5 into height of the cone is 8 into 3 by 4 into, so radius it will become 1 by 0.5 into 1 by 0.5 into 1 by 0.5 is equals to n. So here you are going to get further simplification, you will get n value. After getting the n value, you have to do 1/4 of n value. You will get number of lead shots. Since why we are doing 1/4 of n value means, since he is giving the clearly question that when you are putting these lead shots, 1/4 of the water is flowing out. So whatever the number of lead shots you are going to get, you have to multiply with 1 by 4. So whatever the final answer you are going to get, that will be the number of lead shots. Next question, sixth question. Okay, next, sixth question of exercise 13.2. So a solid iron pillar. So there is one solid iron pillar. On this there is another iron pillar. So height 220 centimeter and base diameter is 24. So 24 and 220 centimeter. Next on the top, the height is 60 and radius is 8. Radius is height is 60. So same case here, given height of cylinder 1, which is 220 centimeter, and radius of cylinder 1 they have given diameter, so it will be 12 centimeter. Next, height of cylinder 2, (60 centimeter), so radius of cylinder 2 which is 8 centimeter. So volume of iron pole is equals to volume of cylinder 1 plus volume of cylinder 2. So that is pi r square h plus pi r square h. See here, the radius of the first cylinder and radius of the second cylinder both are different, so we can take only pi value as common, and moreover in this question is giving the pi value as 3.14. So r square plus h plus r square plus h. Substitute the values, you will get the answer of this volume of iron ore. Next, coming to 7th question. So the question is, a solid consisting of a right circular cone standing on the hemisphere is placed upright in the right circular cylinder full of water such that it touches the bottom. Okay, upright we are keeping in the cylinder such that it is going to touch the bottom. Cone height. So height of cone, which is 120 centimeter, radius of cone. So in this, radius of the cone is 60 centimeter and the radius of hemisphere so radius of the hemisphere also 60 centimeter. So we need to find out. Next, he has given that height of the cylinder, which is 180 centimeter and radius is 60 centimeter. So it may not be the big one. Why? Because total height of the cylinder is 180 centimeter. So in this we are placing the cone which is of the height. So we are placing only this much cone height, which is of only 120 centimeter, not the 180 centimeter. So it will be quite less compared to that. So we need to find out this. So volume of water left is volume of cylinder minus volume of solid. So volume of the cylinder formula is pi r square h minus volume of the solid. So we have two figures here, volume of cone plus volume of hemisphere. That is pi r square h minus volume of the cone 1 by 3 pi r square h plus 2 by 3 pi r cube. So if you substitute the values in this, you will get the answer. So how much volume of the water left is nothing but from the total cylinder volume. If I remove this volume, I will get how much water is going to left. Next, 8th question. So a spherical glass vessel has a cylindrical neck. So has a cylindrical neck, 8 centimeter long and 2 centimeter in diameter, 8 centimeter long and 2 centimeter in diameter, and spherical part, diameter of the spherical part is 8.5 centimeter. So diameter is 8.5 centimeter. by measuring the amount of water it holds, a child finds out 345 centimeter cube. Check whether she is correct by taking the pi value as 3.14. So first, given diameter of cylinder, which is 2 centimeter. So radius of cylinder, which is 1 centimeter. Height of cylinder, 8 centimeter. So diameter of sphere, which is 8.5 centimeter. So radius of sphere, which is 8.5 by 2 centimeter. So he is asking you the question, volume. So volume of solid is equals to volume of cylinder plus volume of sphere. So volume of cylinder is pi r square h, volume of the sphere is 4 by 3 pi r cube. So in this question pi value is 3.14. So pi, if I take common, r square plus h plus 4 by 3 r cube. So take the pi value as 3.14, radius and height already there in the question. If you substitute, you will get the answer. If you are getting the answer as 345 centimeter cube, then you can say that it is correct. So whatever that child is saying, it is correct. Otherwise, it is wrong. If you are getting the other answer, you have to say that the child, whatever he is saying, it is wrong. Okay, next, let us move to the next exercise. Exercise 13.3. Let us go with the first question. So exercise 13.3, the first question. It is a metallic sphere of radius is melted in the shape of the cylinder. So a sphere shape, we are melting in the shape of a cylinder. So since we are melting from one shape to another shape, the volumes will never change. So here the dimensions are, radius is 4.2 centimeter and radius is 6 centimeter in this. We have to find the height of this cylinder. So given all the dimensions, we can write. So here the concept is volume of sphere is equals to volume of cylinder. Since the volumes will not change if it is changing from one shape to another shape. So volume of the sphere is 4 by 3 pi r cube is equals to pi r square h. So r value is 4.2 you can take, and here h value you can find out transposing this. Pi gets cancelled. So whatever the left values are there, 4 by 3 r cube is equals to r square into h. So this h value we need to find out. Remaining all values are there in the question. Next, coming to second question. Same exercise 13.3, second question. So the question is metallic spheres of radius. So there are three metallic spheres of different size. So this is 6, this is 8 centimeter, this is 10 centimeter. So three metallic spheres we are combining and we are making a big sphere. So we have to find out the radius of this. So it means that we are changing from one shape to another shape. So the same concept applies here. Volume will not change. So right here given things, radius and all those things. So here the concept is volume of the formed cylinder is equals to volume of the formed sphere is equals to volume of sphere 1 plus volume of sphere 2 plus volume of sphere 3. So that is 4 by 3 pi r cube is equals to, we can mention it as r1, r2, r3 for our convenience. So 4 by 3 pi r1 cube plus 4 by 3 pi r2 cube plus 4 by 3 pi r3 cube. So we can take 4 by 3 pi common. So R1 cube plus R2 cube plus R3 cube. So if you substitute R1 value, R2 value, R3 value, you will get the answer of radius. So 4 by 3 pi gets cancelled. So R cube is equals to whatever the value that you are going to get in this. Next, third question. So in third question, a 20 meter deep well of diameter 7 centimeter. So well will be in cylindrical shape. So a 20 meter means height of the cylinder is 20 and diameter is 7 centimeter. So diameter is 7 centimeter, height is 20. 7 meters, not 7 centimeter, it is 7 meters only. We are spreading in the platform. So we are making like a platform like this with a length as 22 and a breadth as 14 meters. So he is asking find the height of the platform. It means that from the cylindrical well, if we are keeping the mud outside and if we are keeping on throwing on one shape, so this rectangular shape will turn into a cuboid shape. It means that, so first you write the given dimensions all. So it means that volume of cylinder, and moreover in this also the same, we are converting the cylindrical shape into the cuboid shape. So volume of the cylinder is equals to volume of cuboid. So volume of the cylinder pi r square h is equals to lbh. Length and breadth are already there. Height we need to find out. So radius, here it is 20, radius is 7 by 2, total diameter is 7, so it will be 7 by 2. So 22 by 7 into 7 by 2 into 7 by 2 into height is 20, 22 into 14 into h. So better you transpose to one side and do cancellations first. You will get the height value, height of the resulting platform. Next, we will see the fourth question.